go. Okay. So, good morning. If anybody wants to tell me something fun or positive from your 3-day weekend, feel free to share that in the room chat. All right. So, today we're going to start off by trying to remember some things that we talked about last week. And you're going to notice it's going to lead right into today's session. Oh, awesome. Aubrey, Oklahoma. Cool. All right. So right now in the room chat, before we list out the domain and range, I would like for you to tell me what is the domain? It's the set of what values, and what is the range? So if you could tell me in the chat. Yeah, good. So the domain, good, Nola. Good, Micah. The domain is going to be our X values. I will write that up here. Oops. Man, my pen is like so laggy today. Okay. Domain. Set of all X values. Good. And then our range is the set of all Y values. And I have, I'll put it up in 2 slides, but I have 2 ways that might help you remember which is which. So the first way is just if you think about the order of the alphabet, X and Y. So X obviously comes first, comes before Y. And in the words domain and range, D comes before R in range. So you can kind of think like, okay, which comes first, X or Y? X, so then X is domain. So if that helps you at all, great. If not, you've already got it down. Totally fine. You don't even have to remember that. But for those of you that might be struggling to remember, that might be a helpful tool for you. So the first thing we're going to do is list out all of our X values. So we're going to list out the domain. X values are the first number in an ordered pair. So then our domain here, no worries, Nate, would be 2, 4, 6, and 8. Our range is going to be all of the Y values. Exactly. Good, y'all. So it's going to be 7, 11, 15, 19. Okay, so that is what we talked about a little bit in last week's lessons in the course, was just identifying domain and range. Today, we're going to review domain and range of linear functions, and we're also going to work on identifying domain and range of quadratic and exponential functions. So a little vocab review. The domain is the set of all the values of the independent variable. So last week we talked about independent versus dependent variables. The independent variable is your X. The dependent variable is your Y. So actually let's do, I'm going to put in my, just a second. I'm going to paste the, it's called a mnemonic device, but it's just like a silly word. It's kind of like PEMDAS that you can that you can like add to your notes and reference. If you ever like have a question or like just want to look back at it, it just has a couple keywords that might help you to determine like, okay, which of these is the domain, which is the range, how do I keep them separated, how do I know which is which? Because sometimes it can be confusing when we're talking about independent versus dependent variables. And also, it's harder when we get to word problems sometimes because it's not always clearly labeled. This is X and this is Y. So my picture is somehow not loading. All right, I will write it out for you. So I'm going to go to whiteboard. There we go. All right. So the first word is going to be, it's kind of a funny word. Let me make this bigger. Dixie, D-I-X-I. And the second word is roid. So you can remember Dixie and roid. So Dixie, the D stands for domain. The I stands for input. The X is for X values. And then the second I stands for independent. So all of these independent are just other ways to say domain. So I could interchange these words. Input is the same as domain. X values are the same as input, which is the same as domain. Independent variable is the same as domain, input, and X values. Okay, so I just want you to see all of these words written out. That's why I'm showing you this, so that you understand we can use other terms to describe range, Y values, that sort of thing. So that in the word roid, R is going to stand for range. O is going to be output. So we're going to input our X or our domain, and then we get a number out. That's our output. Okay. Also the Y values and also the dependent. Man, why is that word so hard for me to spell? Dependent variable. Okay, so I'm going to pause here for a second if anybody wants to write that down or take a picture. All right, so back to our slides. We go back. There we go. This next slide is just another way to say all of that. Okay, this is another representation. I tried to color code it for you. So the domain is going to be everything in pink. The domain is the set of all the first values in the ordered pair, which is also the X values. Okay, so all of these little words down here are just different ways to represent X variables or the X coordinate, and then different ways to represent the Y. So we have domain and range, X and Y, input and output, and then X and F of X. So F of X is another way to say Y. Okay, so let's get to some of the new stuff that we're going to be talking about today and that you've gone over in your course just briefly. This is a graph of a linear function. It's a straight line. And it tells us that the domain of a function is the set of all the x coordinates. So I'm going to highlight the x-axis down here. Right now, we are going to write out the domain for this linear equation. So what I typically like to do is start on the far left side of any graph that I get, because we always want to list our domain from smallest to biggest. Okay, so I want to start on the left side because that's going to be my smaller numbers. So if I find my first endpoint on the left side and circle it, okay, remember we want domain. So we don't even want to take a look at any of these y values. I think sometimes the tricky thing is when we circle this, we see this 6 that's a little bit closer, and we think, oh, 6, but we want the domain. So we don't want to talk about x or y values right now. So I circle this endpoint, and I'm going to go straight down. And what would that x value be? It would be 3. Now I'm going to go to the far right side and circle that endpoint, and that x value is going to be 12. So we write this as an inequality because we want to include all numbers on this line. So all numbers between 3 and 12. So we're going to write it as an inequality. What this inequality means is that x is greater than or equal to 3, but less than or equal to 12. There's another way we can write this, and it's called interval notation. And we're going to use these square brackets because, and I didn't mention this on the inequality, but these endpoints are colored in, which means they include those numbers. So that is why we included the less than or equal to. So for interval notation, we're going to use those squares. So this says x, the domain, includes all numbers from 3 to 12, including both 3 and 12. Okay, I'm going to pause here to let you catch up. Any questions? Okay, so we use the number 12 because, let me highlight it for you. This endpoint is the farthest right that our inequality or that our linear equation goes. So then I'm going to go straight down to find that x value. It's the biggest x value. After x is equal to 12, our linear equation does not continue on. Good question. Okay, so now let's go ahead and talk about the range. So the range of a function is all of the y coordinates. I'm going to go ahead and highlight the y values. If you want to cross off the x values, you could, just so you're not confused. So when we're talking about y values, which is range, y values go up and down on a graph. So we want to start again with our lowest value. So we're going to start from the bottom. So here's our endpoint, and I'm looking over what is that y value? 6. I'm going to find my next endpoint. What is that y value? 12. And this time we're going to use our less than or equal to signs because they're still shaded in. And we're going to put our inequality. Good question, Marley. So if the circles are open, we would just use a less than sign. Or in our interval notation, we would use parentheses and not the square brackets. Good question. We're actually going to see that circumstance on the next slide. All right, so then if I wanted to write this in interval notation, it would be 6 to 12, including 6 and 12. And this is going to be all numbers. So we use this inequality when it can be any number in between 6 and 12. we have to use a list when it can only be whole numbers or something between. But since this is a continuous equation, there's no breaks in the line. Oh, and all right, so let's try this one. What is the domain of the function? So just by reading this question, I can eliminate 2 of my answer choices. Which 2 answer choices could I eliminate and why? Okay, so yeah, good. So what I was going for was B and C, sorry, A and C. The reason I say that is because where we want the domain, but you can see that the variable in between is a Y value. So we can get rid of those. All right, so what I'm going to do is go ahead and that's okay. So that's kind of the tricky part sometimes about domain and range is that they'll just switch up the variable that's in the middle. And you will just see the correct numbers, but not the letter in the middle, and that will cause you to choose the wrong answer. All right. So domain, we're talking about X values. So let's start on the left-hand side, and we get to our first endpoint, which is right here, and it's an open circle. And that value is going to be at -2. And I'm just going to use a less than sign because of the circle is open. And I find my next one, go up, that value is at 6. And it's a closed circle. So that one's going to be less than or equal to. So those of you that are saying D, you are right. If you wanted to write this in interval notation, you would use a parentheses with -2 and then that square bracket with 6, which means it starts at -2 but doesn't include -2, and any number up to 6 including 6. The sign is never going to flip because we're not solving an equation here. We're just listing out a range of numbers, but that's a good question. Okay. Let's go ahead and try this one. So I'm going to put up a quick poll here real quick. I'm going to give you 2 minutes to think about it, and then I'm going to explain how we do this. All right, so we've got about 30 seconds left. Even if you're not sure, just give me your best guess. And you can read the problem, okay? It's asking for the range. So there are 2 options we could automatically eliminate. Yeah, good. A and C can be eliminated. Okay, so let's go ahead and read through this problem. It says the daily cost of hiring a plumber, Y. So Y is the total cost, daily cost. Daily cost of hiring a plumber to work X hours on a repair project can be modeled using a linear function. The plumber charges a fixed cost of $80. So fixed cost means you're going to get charged $80 per day, plus the additional cost of $45 per hour. So let's write out what that equation would look like. We would have Y equals $45 per hour, so 45 times X, plus the $80 fixed cost. Then it says the plumber works a maximum of 8 hours a day. Okay, so the 8 hours per day is talking about what we would plug in for X, right? And X is our independent variable. That's what's going to change. That's what our input is. So the X, or the hours per day, is going to be our domain. So for this question, before we can figure out the range, we first have to determine the domain. Okay, so the domain is from 0 to 8, right? He could work 0 hours per day, or he could work a maximum of 8, but not more than 8. So now that we know what our domain is, we can plug that in to our equation. So we would get Y equals 45 times 0 plus 80, which would just be 80. And then we would get Y equals 45 times 8 plus 80, which would give us 440. So if I rewrote this as my inequality, the cost of the plumber is going to be at least $80 and no more than 440. Okay. Any questions about that one? I'm going to pause for a second to let you get caught up and think of any questions. All right, so I'm going to go ahead and put up another problem. This is the last multiple choice one that we do for the word problems for linear. So again, this is asking for the range. It already gives you the function here. Of weights includes a 4-pound barbell and 6 pairs of weight plates. Each pair weighs 20 pounds. If X pairs of plates are added to the barbell, the total weight of the barbell and plates in pounds can be represented by F of X equals 20 times X plus 4. So they're wanting the range. Remember from the last problem, before we can determine the range, we have to determine the domain because we have to plug in the domain to get the range. So let's talk about the domain of this problem. The domain is what we changed, our independent variable. We are changing how many pairs of weight plates we put on. And how many pairs do we have total? We have 6. So the domain, this is where we're going to use a list. This is not going to be an inequality because we have to either put on 0 pairs, 1 pair, 2 pair, right? They are pairs. So we can't split them in half. We can't have 2.4 pairs. Okay, so it has to be whole numbers. So our domain, we could put on 0, 1, 2, 3, 4, 5, or 6. Now that I've determined my domain, I can plug in the domain to my function to find the range. So the range, if I plug in 0 for X, that would be 20 times 0 plus 4. So that would be 4. Okay, and then every time I add a pair of weight plates, it increases by 20 pounds. So it'd be 24, 44. Okay. Any questions about that? Okay, so let's go ahead and talk now about how to determine domain and range from a graph of a quadratic. So this is just like a pretty lengthy method. You don't have to use this method, but I do think it's helpful to keep you organized. So step number 1 says use horizontal and vertical lines to draw a box around the graph that is shown below. So let's go ahead and do that. It says be sure no part of your graph is outside the box, and be sure the sides of your box are touching the graph using the smallest box possible. So let's go ahead and do that. So this is this little point right here. Whoa, that is supposed to be a straight line. 1 second. Let's see. I can get a straight line. There we go. So I'm going to draw a box. Go all the way over to this point. Come up. Whoops, I went a little too far there. There we go. And then I'm going to come back over. Okay, so we're going to draw our box. Now, number 2 says highlight the left and the right side of your box. So I'm going to go with green and I'm going to highlight these sides. It says record the smallest number and the largest number when looking at your box from left to right. So on the left-hand side, I want this X value. And that number is going to be -3. It's kind of hard to see. Those numbers are so small. But negative, there we go, 3. And my largest number is going to be 5. So now it says write the set of all the X values. So this graph starts here and goes up and over until it ends right here. So it's going to include all the numbers from -3 to 5. And then obviously these are X values. So this is going to be called, whoa, our domain. Questions about how I got any of those numbers? Okay, good. So let's go ahead and talk about the next part. It says using a different color, highlight the top and the bottom. Record the smallest number and the largest number when looking at your box from top to bottom. So my smallest number down here is -70. My largest number is 150. So -70 to 150 are my possible y values. And we know that all the possible y values are called the range. Some of you may not need to draw the box and highlight, but for some of you it may be really helpful. Okay, so I just wanted to show you that method in case that is helpful to you and you can't see it on your own. So the quadratics can be tricky because the endpoints are not always the highest and the lowest points. All right, so now we're going to try to write this one out by ourselves. So the domain, and then we're going to write out the range. So domain, remember, is our x values. So here's my farthest left point. It's at 0. And it's a closed-in circle. And it's continuous all the way until this point, which is at 4. Yep. So we want to write it as an inequality. Oh, that is a funny one. Or if we wrote it in interval notation, we would use these square brackets. All right, so now let's talk about the range. The lowest point is going to be down here at 1. And our highest point is up here at 5. Or if we wanted to write it in interval notation, it would be 1 to 5 inclusive. Okay, I want you to try this next one on your own. I'm going to put up a poll here. Be careful at what letter is in between your inequality. All right, so we know from just looking at this that we can eliminate C and D because it's asking for range. So basically what we have to decide is, does it include 0 or does it not? And does it include 100 feet or does it not? And this is the path of a golf ball. And so you can see it touches this 0 down here. And also when we get to 100, this graph is continuous. There's not like a gap or anything in it. So that means it's going to include it. So our correct answer is B. Good job. All right, I've got one more problem for us. I want you to pay close attention to these endpoints. So without me saying much, I want you to go ahead and answer this question. and then I'm going to go over it. All right, so if we're talking about the domain, we want to find the left and the right. So this is our left endpoint, this is our right endpoint. But what do you notice that's different about these endpoints that wasn't on any of the graphs before? They're arrows, exactly. Yes. So AJ, they're continuous. So it's not a hard endpoint. Arrows indicate we're going on to infinity or negative infinity. So on the left-hand side, it's going to continue going on into these negative x values. On the right side, it's going to continue to positive infinity. So the domain goes from negative infinity to positive infinity, which is actually all real numbers. Okay, so that was kind of a special case one, but I just wanted to show you so that you are aware an arrow indicates going on to infinity. So if we were talking about the range for this one, so if it's upside down, same thing. It's still going to go to positive and negative infinity for the domain, but the range would be different. So the range for this one, our lowest value, let's just pretend that's negative 5.5. Okay. And then our y values, this is our highest point, but they're arrows, so they're going to go to infinity. So you would say that they go to infinity. Or it would be all real numbers greater than negative 5.5. And if it flips upside down, it would be all real numbers less than. Good question. Really good question, Micah. Okay, so what I want you to do now is if you have not taken your done your 2.07 homework, I want you to go log into ClassKick right now and log in to do that. If you do your homework and you seem to get it, you totally understand it, go ahead and take your quiz. That's also in ClassKick. Okay, so I'm going to give you these 5 minutes to get some work done in class. Okay, thank y'all so much for coming. I'll release the recording and y'all have a great day.